Hello, greetings. This is Dr. Costa from costamedic.com, and in this video I would show you how to do a chi-square test. A chi-square test is done to assess the association between two categorical variables. This is our Spss dummy dataset. In this factitious dataset, we have one categorical variable which is gender, and the categories are male and female. Our another categorical variable is marital status, and the categories are single and married. We can do a chi-square test to assess the association between gender and marital status. In order to do a chi-square test, we would first go to analyze, then descriptive statistics, then cross-tabs. In this cross-tabs box, we would put gender in rows box and marital status in columns box. You can also put it other way around. For example, you can put marital status in rows box and gender in columns box, and the results will be the same. Under the exact, I would not do any changes. Under the statistics, obviously I would check chi-square. I would like to see the contingency coefficient and phi and Kramer's V. I would also like to see the risk. This risk is represented as a risk ratio or odds ratio, which is very commonly presented in the test results in the journals. Click continue. Under the cells, I would like to see the observed and expected counts and percentages for row, column and total. Continue. Under the format, I would keep it as it is. Now we are good to run the test. Click OK. This is our chi-square test result. The first table of the cross-tabs results is case processing summary. It is simply showing we have total 20 valid cases and 0 missing cases. The second table or actual cross-tabulation table is showing that we have total 14 married cases and 6 unmarried cases. In these 6 cases, 4 were female and 2 were male. In these 14 married cases, 7 were female and 7 were male. It is also showing the expected counts for males, females and total. This is the most important table because it is showing the chi-square test significant value. In this table, this 0.492 is the chi-square test significant value. You would normally present this value in your research paper as p-value. But one important thing is, here it is written 2 cells 50% have expected count less than 5. The minimum expected count is 2.70. Here 50% is too much. It is way more than 2.70. So we cannot present chi-square significant value as our p-value. Instead, we can do is we can present Kramer's V significant value. In our case, both values are same 0.492, but for other data both values may not be same. So if this type of messages are shown below the chi-square test table, then you would present Kramer's V significant value as p-value instead of chi-square significant value. The last table is showing the risk estimate. Here this value 0.500 is the odds ratio for our test, and these are the 95% confidence intervals. Now I would like to talk a little bit more about chi-square test. We did the chi-square test between two dichotomous variables. In our example, we showed association between gender and marital status, and the p-value was 0.492, which is not significant because it is more than 0.05. So we would write that the association between gender and marital status was not statistically significant, and then we will write our p-value. Here we did analysis between two dichotomous variables. By dichotomous I mean gender variable have two attributes, male and female, and marital status variable also have two attributes, single and married. Now look at this variable job title. It has three attributes: lecturer, assistant professor, and professor. So this is not a dichotomous variable. We can also do a chi-square test between variables with two attributes and with more than two attributes. For example, if we do a chi-square test between gender and job title, analyze this cross steps under descriptive statistics. Here we are putting the job title into the columns box, and everything was previously selected because I did not make any changes. So I would just press OK. Here one thing you should notice is the odds ratio table is empty. Odds ratios are only presented when chi-square test is done between two dichotomous variables. If one of the variable or both of the variables are not dichotomous, then odds ratio will not be presented. Another thing, here we have chi-square significant value 0.390, and again 83% have expected count less than 5, which is way too much. The minimum expected count is 1.80. So in this case we cannot present chi-square value. In this case we should present likelihood ratio instead of Kramer's V. If these two variables were dichotomous, we would take Kramer's V. Since one of the variable is not dichotomous, then we can also take likelihood ratio. So in our results we would write that the association between gender and job title was not significant, and p-value is 0.381. Thank you for watching. Please visit our website, which is www.costamedic.com. We do medical illustration, animation, data analysis, and medical article writing. We also have a very informative medical blog. Thanks once again.